is live.
Good morning, everybody, and welcome to today's webinar, which will be about nurturing young talents. So that means we'll be talking about the Young Scientist Award from the SJU. Just a few technicalities before starting and leaving the floor to the award winners that we have today with us. You have on your right side of the screen a few tabs. For the question tab, whenever you have a question to be raised to any of us or any of the winners, please do it. We will try to reply online as much as possible, and we can pick some questions also for the discussion panel that we will have after their presentation. So I propose to start, and this is the agenda for today. For the ones who don't know me yet, I'm Luca Greco. I'm working at the SJU as ATM expert, and I've been following the award competition inside the SJU for the last 3 years. Today with us, we have 3 winners from some previous editions of the award. We have Gianluca, winner in 2018. We have Floris, winner in 2015, and Manuel, winner in 2013. We will go through their presentations, about 10 minutes each. And after that, we will have, as I said, panel discussion, mostly focusing on if and how the award improved and how their professional life has improved, and on how the ATM industry can help stimulating and nurturing young scientists and young talent in ATM and aviation. I will be closing the webinar in about 1 hour, more or less, with some closing remarks. Before giving the floor directly to the winners, just a few reminders or a few information regarding the award itself, on what is the award and who can apply and when is the award granted. So the Young Scientist Award is a SESAR award aiming at recognizing young scientists, young students and scientists with high potential contributing to the research in ATM and aviation. We have set up a mechanism through which we also try to improve the professional and personal development of the winners. The award is public, so it is awarded following a public contest. And it is about the what. About the when, there is an award every year. So usually beginning of May, there is the publication of the call, which usually closes beginning of September. Then there is the evaluation phase, followed by an award ceremony, which at least, which is usually held during and contextually to the SESAR Innovation Days, where we usually invite the 3 shortlisted candidates without, of course, telling them in advance who is the winner. And then there is the award ceremony directly at the SITS. This year's edition, the 2020 edition, will be the 8th edition of the award. Regarding the who, I would like to say basically anyone, any young scientist who is contributing or has contributed to scientific achievements within ATM and aviation, within either a bachelor thesis defended no more than 18 months before the date of closure of call, or master thesis, or PhD thesis, or even an ongoing PhD. Doesn't matter. Having said that, and before moving to the panel discussion, I leave the floor directly to the first winner, who is Gianluca, the winner from 2018 edition. So, Gianluca, the floor is yours.
Okay, Luca, thank you for the introduction and good morning to everybody. I'm going to present something regarding my research so far that is mainly focused about applying neuroscience in the service of air traffic management. So first of all, some words about myself. I'm Gianluca Di Flumeri. I'm a biomedical engineer and I achieved a PhD in biophysics in 2018. So essentially some months before achieving the SESAR Young Scientist Award. And currently I'm a postdoc research fellow in cognitive neuroscience. I know this event is related to aviation, but I assure you that I'm not in the wrong event. In fact, in the 2018, I obtained the SESAR Young Scientist Awards because of my PhD thesis that was titled Electroencephalography-Based Measures of Human Mental Workload in Operational Environments for the Development of Passive Brain-Computer Interfaces. Here on the right below, you can see, for example, a picture of our experiments. In particular, in this case, we were along the STRESS project funded by SESAR JU as well. But before going through the presentation of some of this research, I'm going to explain you some very preliminary concepts in order to facilitate your understanding of the topic. We, in our daily life vocabulary, we used to use the word biometrics. Biometrics is the technical term for talking about body measurements in general. So biometric identifiers are the distinctive measurable characteristics used to describe individuals. For example, measurements of our body, but also fingerprint, face recognitions, and so on. Along this presentation, I'm going to use a new concept that is the one of neurometrics. Neurometrics that we can intend the neurometrics word within the large set of biometric is a technical term developed during the last decade thanks to the research performed by the field of neuroscience. The neurometrics word stands for the measures of human mental states, such as, for example, the level of attention or workload or stress of an user while performing a task. So we put the prefix neuro before the word metrics because these measures are based on the relation with human neurophysiological activities. So the overall concept is to record from the human body some signals, some physiological signals, such as, for example, the EEG that is related to the brain activity, eye gazes that are related to ocular movements, ECG related to heart rate, or GSR related to skin sweating, and other similar signals that I will call them just biosignals. And through a specific biosignal processing, we are able to obtain neurometrics of specific mental states, such as I told you before, vigilance, stress, and workload. The aim of performing this analysis is to use these neurometrics to perform an overall evaluation of the user psychophysiological states. And I would like to highlight how this domain, this field of research is extremely cross-domain, since in this case we applied this matter related to aviation and air traffic management, but we performed the same kind of research applied, for example, to aircraft pilots, as well as car drivers and so on. So in almost all the fields where it is very crucial and important to perform a human factor assessment. But why the use of neurometrics? Neurometrics, the need of using neurometrics comes from the need of obtaining objective information about the user psychophysiological status while dealing with operative activities. Because there are already a lot of well-established traditional methods, such as, for example, questionnaires or measures retrieved by performance of the user with the systems and so on, or also evaluation from an expert. But in terms, for example, of self-assessed measures, they are intrinsically subjective, and also they cannot be collected while operating. Also, the user usually is not aware of an incoming psychophysiological impairment, for example, the drowsiness. In addition, supervisor assessment for sure could have a certain subjective bias as well, even if it is expected that a supervisor is a little bit more objective than the self-evaluation. And also, sometimes mental state degradation could be covered. For example, if I'm going to be drowsy, a supervisor, maybe it is not able to detect him before it happened. And system data as well often highlight risky behaviors after the fact. So in this context, neurophysiological measures could provide objective information, first of all, about human mental states. Also, we can use neurometrics online without allocating an additional task for the operators. These measures are able to, even anticipating self-awareness, they are able, for example, to detect incoming increasing stress before we are aware of it. And finally, they can be used as a communication channel to enhance human-machine interaction. In this case, for example, on the right, I put a GIF that is representing this concept, that is the concept of brain-computer interfaces. So we estimate mental states from the user through his physiological signals, and we use this estimation to adapt the level of automation of the user. And this was, in particular, the application evaluated along my PhD thesis. So essentially, the reason why I achieved the SESAR Young Scientist Award. This work was performed along the NINA project, a SESAR project founded at the beginning of 2014. In this case, through a collaboration with INAC, so the École Nationale of Aviation Civile in Toulouse, and Deep Blue, that is a human factor consultant company here in Rome. We did this study with 12 air traffic controllers while dealing with two highly realistic scenarios. Actually, they were working in a real workstation, performing realistic simulation scenario normally used for training. There were also two aircraft pseudopilots involved, and they have to use two different interfaces. In one, when the adaptive automation was disabled, actually his workload can increase or decrease, but the level of automation was disabled along the whole task. While in the other scenario, according to the level of workload estimated through neurometrics from the controller, we were able to increase or decrease the level of automation in order to support the operator. So how you can see here in the bottom, when we detect an increasing of workload, so a situation of overload, we increase the level of automation of the interface in order to support the operators. And what we obtained was very relevant, since we demonstrate how, by using adaptive automation, so by using neurometric workload to help the operator, we were actually able to reduce the level of workload of the hard part of the scenario. So actually, there was no significant difference when the adaptive automation was enabled between the easy and hard part of the scenario. And here, for example, in the C corner of this picture, you can see with the red line the workload dynamics of a subject, of a relevant subject, where the adaptive automation was disabled, while with the green line, the time course of the workload of an operator when this adaptive automation was enabled. So you can see how each time the workload was going over, the activation of the automation was able to mitigate this increasing. So what has been the evolution of the research currently? Actually, human performance degradation results from the interaction of multiple human factors, not only workload, but also, for example, the level of attention or vigilance of the controllers. In fact, in the aviation domain, it has been developed the concept of human performance envelope. That means that human performance are based on the interaction of multiple factors. So through this model, there are the relevant human factors, the related scales, and the performance of the operator is the result of this model. So we are able to define a region where performance can be tolerable and where it starts to become hazardous. What we are trying to do is to use neurometrics to measure each of these human factors in order to obtain the human performance envelope assessment. For example, in another SESAR JU funded project that was Minima, we performed a very similar research such as the previous one, but based on the concept of vigilance. In this case, we evaluate two different scenarios, one that is related to the state of art and one where a scenario of the future was evaluated with very high levels of automation that could induce the out-of-the-loop phenomenon in the controllers. And by using a vigilance monitoring techniques based on EEG, we were able to counteract the vigilance decreasing along the highly automated scenario. And these videos, for example, is telling you something regarding the stress projects that is another SESAR JU funded project, where actually we tried to measure each one of the human factors composing the human performance envelope. So by using a multimodal evaluation based on EEG, ECG, body posture, for example, skin sweating, galvanic skin response, we were able to measure each one of these human factor components, workload, attention, vigilance, and stress, in order to evaluate how automation solutions can impact over the operator performance. Now, I know my time is almost finished, so just a few words about the future trends of this kind of research. For sure, we have research on one side, since I demonstrated you, and it is evident how through this kind of application we are able to obtain insights about cover or unconscious reasons of human behaviors. But for sure, this kind of application can be used also in industry in order to evaluate all the new concepts of human-centered design, so to evaluate human-machine interaction with the workstation, dashboards, cockpits, and so on, but also to develop this very groundbreaking technology based on brain-computer interfaces in order to enhance human-machine interaction. I would like to conclude by saying that also thanks to this award, I'm now collaborating with a company based in Rome that is Brain Science, that is focused on applying neuroscience. And also thanks to these awards, I was able to produce a lot of very scientific outcomes, such as a book, a lot of high-impact scientific publications, and also I obtained a patent. So the time for me is almost finished, so I'm very honored to leave the floor to Floris, that is the 2015 Young Scientist Award winner. So Floris, I leave the floor to you.
Thank you, Gianluca. I'm going to present my slides. Can you see my slides? Yes. Okay, so thank you, Gianluca. First of all, I would like to thank SESAR for giving me this amazing opportunity to present additional capacity with machine learning. I've won the Young Scientist Award in 2015 for the work a better understanding of the behavior of aircraft on final approach. And this has, for example, a direct impact on safety, as well as the reduction in separation between pairs of aircraft on final approach. This was very...
Luca, sorry, Floris, sorry, we cannot really see your slides.
No, okay.
I also see a black screen.
Okay. I start over then. You hear me, right?
Yes.
Okay. So you don't see my, but you heard what I was saying?
Yep.
Okay. Can you see it now?
Yes, thank you.
Yes, okay. So I continue where I was. So this work was very useful work, but was also limited on predicting abnormal aircraft behavior. And with this respect, I decided to go progressively over from a statistical approach to a more machine learning approach for coping with the variability of aircraft behaviors. And for such an efficient deployment of a new concept, we needed to look into reliable predictions of aircraft operations, aircraft behavior, what-if cases, complex interactions between ground and air operations, and of course, by including methodological parameters. So for going over to such a machine learning approach, I first wanted to understand how to include this into the ATC system. So before doing so, I've looked into the controller position of the 70s and compared that position to his or her position today. Basically, not many elements have changed. For example, you still see 2 air traffic controllers in the 70s and 2 air traffic controllers today. You see, compared to an analogical display that we are using now, more digital displays. But basically, the key element that is changed, which are more multiple support systems that enhanced not only the controller by anticipating on something that is likely going wrong, but also on decision making. So that's exactly where I focused on over those last 4 years. So after winning the SESAR award. And by doing so, we focused on specific elements, like all elements that are impacting not only runway throughput, but also in order to maintain safety. So I've looked into taxi out time predictions, runway occupancy times, runway exit utilized, runway occupancy times. And today I will only show you 2 examples. The requirements from the controller were actually, we needed to have a machine learning model that was fast in order to anticipate quickly, of course, accurate predictions, but also a model that is intuitive and interpretable so that he understands the key precursors that are influencing abnormal behavior. And of course, to show the predictions on a nice HMI screen, visualization tools, or human-machine interface. So basically, that entire machine learning algorithm has been validated into our simulator in Bretigny, in the Eurocontrol simulator. And I will come back to this slide at the end of this presentation. So I will just show you some examples. So this is an example for the taxi out time opportunity, where we predicted for CDG airport the abnormal behavior of taxi out time. So we've included different variables like aircraft type, terminal, weather, but also airline procedures, time of the day, peak hours, and many more. So what we were doing here is to basically understand or to learn the complex underlying structure of all these variables that we're taking into account based on 3 years of historical information. So basically what we are doing is, for this specific model, we built a regression tree to understand what is likely going to happen for a specific example. So you see here, if we want to predict an aircraft that is leaving from gate E32 to runway 08 left, as I showed you in the previous slide, and we know that it is an Air France A320 to London, we basically follow the tree and try to understand what is the likely taxi out time for that specific flight at a certain time of the day. Of course, it has a certain error value based on a different distribution, but I'm not going to go into detail in that. That's something you can read into one of my papers. So what we have done here is we've built a dashboard for CDG. So this is the dashboard that we've developed. So you can see on the left arrivals and departures that are coming in, but also the taxi out time, and especially the abnormal taxi out times to predictions that were simulated in this environment. So it was connected to the dashboard that you can see on the right. So it's an interactive dashboard where we show runway throughput, weather, time of the day, airline, aircraft type, and many more features that were all captured in this dashboard and connected to the CAST environment, as you can see on the left. So this has all been learned based on a real-time airport database from CDG, and this is still under development. Another opportunity that we've seen is the runway opportunity. So basically you can model it as a regression model or a classification model. So to predict the time, how long the leader aircraft will spend on the runway, or which runway exit it is likely to take. So over here you can see exit 1 till exit 4. Again, we included many parameters like weather, airline, daily seasonal factors, and weather factors. This is the user interface that we've developed for Vienna Airport. So you can see again arrivals and departures that are coming in. And what we wanted to do for this user interface is to alert the controller when something is likely going wrong. So to alert him that it's likely that the arrival runway occupancy time, for example, is higher than the average, or it's way above the normal behavior, as you can see here in red. So the arrival runway occupancy time for a specific leader was supposed to be 71 seconds. So this is very useful work, but all this work was based on post-processing prediction. So we learned the model based on D-1, and we tried to learn it based on historical observations. Now, going one step further, we wanted to look into real-time predictions based on historical observations. And that's what we have done for a different airport, a different use case. So that's actually for Orly Airport, where we've looked into which features do we need to predict a certain runway exit. So for that, we need to have two different sources that are capturing the data in real time. So real-time wind, which is coming from the wind cube here, LiDAR, which is capturing the weather on different altitudes above the ground. And of course, the ADS-B transponder, which is all capturing the flight performances. We cleaned, merged, and analyzed the data and included that into our model. And we simulate that for the Orly environment. So as I said, we wanted to predict it for 4 different exits. And basically, we started to capture the data at 10, as you can see here. So there we captured 5 different features. So wind direction and speed coming from the LiDAR, and the other 3 coming from the ADS-B transponder. We're capturing the same for 5 nautical miles. So 9 in total, because we captured already 5 at 10. You can see here that we are capturing the wind speed and direction at 1500 feet and the airspeed as well. And finally at 2 nautical miles. So by merging all these features from 10, 5, and 2, we learned it based on 1 year of historical information and showed those predictions in real time to the controller on a daily operation. So you can see here we were testing the model exactly at 2 nautical miles in order to capture the data as accurately as possible by our transponder. And after that model, we looked into how the controller would react by working with such a tool. So you can see the real-time simulator here for Brittany on the left and a human-machine interface for the controller on the right. So again, we alert the controller by showing a red light when something is likely going wrong, so a higher runway occupancy time, or for example, a missed intended runway exit, which is coming from the AIP for a pilot. And this helps the controller to anticipate on something that is likely going wrong, so that he can, for example, request the follower to increase speed or to request the leader aircraft to utilize 1 exit earlier or maybe 1 exit later. So concluded, machine learning seems to be very effective, what we have found for all these parameters. So during this presentation, I just showed you a couple of examples, but I can show you many more. Predictions can be computed in just a few seconds which is of course needed when working in real-time operations with such a tool. The tree helps also to make quick and intuitive decisions, so to understand the precursors that are influencing, for example, the runway occupancy time. And such predictions are useful for in-depth analysis of procedural improvement or runway efficiency. And as I showed you, it's more a tactical tool, so to alert the controller. But we also want to go over to a more strategical tool where we alert the supervisor on, for example, that he can change the runway configuration so that he can change the sequence algorithm. And that's very useful for him to predict those parameters in 1 or 2 hours in advance. So with this study, we think that we show a better understanding of the underlying patterns and precursors. And this is really helpful for giving a higher, or let's say, enhance the capacity or the runway throughput, but also to maintain safety. So we are not increasing safety, but it's just maintaining safety as it was during the previous concept. So this is a briefly summarize what I've done over the last 4 years, but I'm happy to explain you it a bit more into detail after this presentation. And I would like to give the floor now to Manuel Soler, who is going to share his presentation right now. I will stop sharing. Good luck.
Thank you very much, Floris, SESAR JU for putting all this together. I think it's a nice opportunity to present our work and foster young scientists for the next edition. I think Remy is, yeah, presenting for me. Okay, so yeah, next slide, please. So I got the SESAR Young Scientist Award in 2013. That is a while ago already. And what we did, or I did, is to develop a mathematical framework based on switch systems and hybrid systems to model aircraft behavior and solve aircraft trajectory optimization problems using nonlinear optimization and mixed integer nonlinear optimization, incorporating constraints and decision making into the problem. That was new at the time. It is already something not new, so I'm gonna try to focus my presentation in what I've been doing and what I intend to do in the next years. One important remark is that I got the SESAR Young Scientist Award because my research was groundbreaking at the time, but also because I was involved in a lot of activities, publishing papers, scientific papers in journals, but also attending international conferences like SESAR Innovation Days, ATM Seminar, and others to kind of start discussing the topic with the experts. I did some research stays at ETH Zurich and UC Berkeley, and I still maintain some links with them. And I participated in different projects and SESAR activities such as the HALA Network Summer Schools and so on and so forth. Next slide, please. So the SESAR Young Scientist Award was in 2013. That was the year in which I defended my thesis. And in 2014, I was invited to give a presentation in front of a qualified audience because I was scheduled, as you see in the right-hand side, together with the big guys. And I could present my work to the stakeholders, SESAR director, and after that, we have a cocktail, and I established some important links for my career. Indeed, out of that cocktail, I developed some of the ideas that I follow up in my postdoctoral research. So next slide, please. So in 2014, I became assistant professor at UC3M. And what I developed as research line was to incorporate uncertainties, in this case, meteorological uncertainties, into the optimal control framework I had developed in my PhD thesis, right? While attending to the conferences, everyone was talking about uncertainties. The reviewers of the paper, they were always saying that you are not introducing uncertainties into the problem. And I understood that weather uncertainties were very relevant to the stakeholders. And there was a product at the time, experimental, called Ensemble Probabilistic Systems, that I incorporated into the modeling framework I developed in my thesis, right? This was funded by a couple of projects, right? We pushed the idea into a SESAR project called TVOMED, and we developed there in a framework for robust trajectory planning. This is the left-hand side of the figure, pre-departure. And also we move into assessing how to avoid thunderstorms, the presence of thunderstorms while flying, right? This is highly stochastic as well. Together with that, I've been also leading one of the Engage. Engage is a SESAR knowledge transfer network that is running today. And I am leading one of the challenges, which is has to do with meteorology and ATM, because there is an existing gap between those two worlds that needs to be bridged somehow. We've also been organizing a series of workshops, putting together these two communities, meteorological scientists and ATM experts. Next slide, please. In last year, I promoted to associate professor, right? This is my current position as a faculty member. I am leading all the teaching activities in the area of airports, air transport, and air navigation. Thus, there is an important link with SESAR and industrial stakeholders. And I'm playing that role of teaching what is to come in the near future in the aviation domain, also trying to set in touch students with the industry, supervising master thesis, etc. I am also director of a brand new PhD program in aerospace engineering, right? Because in Spain we have the aviation domain is together with classical aerospace domains, and we do very different research activities. But in particular, I lead a research group on ATM research, right? This group is composed by 10 people currently, which I'm leading a group of 10 people, which is quite a lot. And I am involved in several projects, including coordinating a SESAR exploratory research for project called START, and involved in 3 SESAR projects currently. I want to focus a little bit on the research lines that I'm now developing. Of course, those research lines are derived based on our previous research. So we always find gaps, ways to go forward, ways not to go forward, and to find some alternative method. And in this case, one of the things we found in our previous research is that optimization is quite slow typically. So we are now doing some research on parallelization and GPU optimization to speed up our calculations with some promising results, as I will show you in a few minutes. Also, we are resorting from exact methods based on mathematics, pure mathematics, to artificial intelligence-based methods, right? We are trying to solve problems using heuristics, meta-heuristics, but also data-driven methods, applying that to problems related with meteorology and air traffic management. And last but not least, there is something that we need to tackle as a community, which is climate change, right? It's been on the floor last year before the coronavirus outbreak, and it's something we need to tackle as a community. For the last 15 years, there is this CO2 emissions reduction, which is linked to fuel burn reduction. That is a win-win strategy, but non-CO2 related emissions have not been studied in depth, and it's something we want to assess, right? As I will show you in the sequence. Next slide, please. So the first research activity has to do with GPU optimization. I mentioned that in my PhD thesis, I was tackling flight planning problems, deterministic flight planning. Here and in my postdoctoral research, I was tackling stochastic flight planning, including wind uncertainties. Well, here we can mix, we can solve a problem that is uncertain, that includes meteorological uncertainties. We can incorporate the structure of the airspace, which is something stakeholders were demanding to bring this to some more realistic stage. And we can solve this within 1 second, right? This is kind of the key result. which is outstanding, I would say. So we can, and this framework is flexible enough to incorporate other objective functions, such as a climatic objective function, to incorporate whatever constraint we might want to incorporate, decision making, etc., 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 within, and we solve the problem within computational times that are compatible with the operation. Next slide, please. Our other research activity has to do with artificial intelligence and meteorology. In this case, we would like to predict early in time. This means 1-2 days before the existence of thunderstorms in the network, at the network level, right? Because in the end, the network manager is to balance capacity and demand. Weather or thunderstorms have been a very impactful phenomena in the network in 2018 and 2019, and we need to anticipate or to early predict their birth and evolution in order to take the appropriate measures. So here we are kind of incorporating ensemble probabilistic systems, so meteorological information in a stochastic manner, and we are building a machine learning or a neural network algorithm to provide a forecast. And if we go to next slide, we see here an animation. The left-hand side is what really happened based on satellite images. And the right-hand side animation has to do with our prediction based on a neural network algorithm, 24 to 36 hours ahead of time. That is the day before, right? This is a preliminary algorithm. We still need to fine-tune it, but it's quite promising since it is improving a lot the existing forecasts that are not able to capture precisely the location and development of thunderstorms. If we move next slide, please. Another activity has to do with the avoidance of thunderstorms in flight, right? For which here, instead of having a thunderstorm forecast the day before, we need to have a thunderstorm nowcast. That is, what's going to happen with weather for the next 1 hour, right? This is something the aircraft need to know to take avoidance maneuvers. And today, there is no enough information because meteorological products are not able to capture this phenomena due to time, space granularity, and weather radars on board the aircraft are providing some information, but not a complete picture of what's going to be the evolution of thunderstorm in the future. So if we go next slide, please, we can see a couple of examples here. The first animation is thunderstorm nowcasting. So this is being refreshed every 15 minutes. So we can kind of know how the weather is going to behave in the next 45 minutes, 1 hour. And this is refreshed every 15 minutes when we get a new satellite image. And we use this information. Next slide, please. Next, please. We can use this information to calculate avoidance trajectories, right? You see that the path is avoiding the storm. Those lines are representing the 2.5%, 5%, and 10% probability of hitting a storm or finding a storm within that area. So you see that the trajectory is always out of the 2.5% probability of finding a trajectory. And this is something we would like, again, to incorporate on board the aircraft in flight dispatcher tools like electronic flight bags or something like that, or even on the ground for controllers, and for which, again, we need to incorporate high fidelity dynamics. We need to speed up optimization processes. And for that, we are resorting or moving to heuristics, meta-heuristics, and GPU optimization. Next, please. As you see in this example, right, this is a rapidly random exploring tree algorithm that is finding equivalent solutions in computational times, again, below 1 second. We still need to do more research to add high fidelity dynamics and actually prove that an aircraft could fly this path. But this is the way we are doing research right now in this field. Next slide, please. And my last slide has to do with climatic impact of aviation. On the left-hand side, left-hand side of the slide, you can see the Schmidt-Appelman criteria, which has to do with temperature and humidity, for which contrails and persistent contrails are created in the atmosphere. You see that the areas, the shadow areas, are kind of very narrow in terms of conditions. This means that we have a lot of uncertainty, right? And we need to understand how the atmosphere is going to behave in order to take actions, right? Because one thing is to understand what is the effect of contrails in climatic change, right? This is one thing. And if you go to the right-hand side figure, you'll see that CO2 is the most important one. Then you have all the contributors. But then if you go down to line-shaped contrails, you see some contribution. And then if you go to induced contrails or induced cirrus, persistent contrail contribution, you see that is at least as important as CO2, but you also see that there's still some lack of knowledge, right? We still need to do some more research to understand what is the contribution of these guys to climatic change. But something is clear, it's at least as important as CO2. So the community should also focus on finding mitigation strategies. And in particular, we would like to incorporate or to develop flight planning algorithms incorporating climatic uncertainty, right, into the models we have developed in the past. So thanks very much. This is all on my slide, and I give the ball to Luca.
Thank you, Manuel, and thank you all for these presentations. It's time for our panel discussion. So meanwhile, I'm giving you guys 30 seconds for drinking a glass of water if you want. Just a few words. I want to stress the fact that, as you saw, the topics which have been awarded are really covering a broad spectrum. And that means that, in fact, we do not have any preference, or the SJU does not have any preference for this or that topic. We are definitely open to receive works and applications from any possible field in ATM and aviation. Again, if you have questions, people in the audience, please use the questions tab to raise your questions. Meanwhile, I'm going to start our panel discussion with the guys. I'd like to ask you, I don't have any order of answers, so feel free to take the floor. From your presentations, I think we already went through an analysis of how your work has progressed since the time you won the award. Just for confirmation, and just if you want to add anything else, winning the award has opened any additional door you has enriched your research in any way? Who wants to take?
If I may,
Yes, Manuel.
First. Yeah, definitely yes. I think this has been very important. I already mentioned that during the presentation I gave in the World ATM Congress, I met a guy from Meteo France, and we started to discuss on how to improve the work that I had been doing for the PhD. And then I knew the ensemble probabilistic systems, and I started to think on new ideas. So that was important from a technical point of view. Also, it should be mentioned that in order to get funding, we need to get projects, right? We need to get PhD co-funding or projects to develop our ideas, to build a team, and to keep progressing. It is an important item to say that you've been awarded with the SESAR Young Scientist Award, not only within the SESAR domain, But if you want to follow a traditional research path in which you would apply for a Marie Curie postdoctoral fellowship and then eventually for a starting grant, European Research Council, as I've done it, but I didn't get the grant. I think it's important. One of the things they evaluate is the curriculum. They evaluate your connections, your leadership, your independence, and they evaluate awards, right? So in this case, having a European award is very important for any researcher following this kind of traditional path, which is a high excellence path. So this is my answer to the question.
Yeah, if I may add to that, I have indeed a similar answer. So when I won the award, I was working on my master thesis at TU Delft, but immediately after I received funding from Eurocontrol to do my PhD. And not only from Eurocontrol, but it definitely boosted or helped us to get funding from a different project. So from an Horizon 2020 project named Safe Clouds. So I think it's definitely recognizing not only in the ATM world, but also in different projects that are related to data science or neuroscience, that such an award for such a high organization like SESAR opens definitely doors for future perspective. So yes.
Yes, Luca, I would also like to add something from my case. For sure, in general, I think that in your life, for sure, you are the first responsible of your career. So you will make the difference. But there is a large set of factors that can help and promote you. And for sure, SESAR JU activity in general, and this award in particular, is among these factors, especially in enlarging your capabilities of making networking, as my colleagues already said. In particular, in my case, since my research is quite at the boundaries of the application field of aviation, this award also allowed the topic of my research to emerge from, let me say, the darkness and attract the interest of the field industry. And also, I would like to remark how these effects are also transversal, since when I did my PhD, I was involved in just one European project, that was NINA, as I told during my presentation, funding my PhD research as well. And at the best of my knowledge, it was the unique project exploring the effective application of neuroscientific disciplines in this field. Now I have been involved in 3 new SESAR JU projects that have been stress mode and minima, but also we start to employ neuroscience in an applied way, also in other transportation fields, such as road, maritime transports. So SESAR JU in general, these awards, has definitely been the big bang for this applied research.
Okay, thank you. I think that there is a common denominator in your answers, that is network, that the award has definitely given you more visibility and has given the others, research centers and industries, more visibility of you, so that you could pick up on that and build on that on your career development. That's, I think, pretty good. And in fact, one of the things that we try to achieve with this award. So, I mean, speaking of industries in general, of the aviation ATM industry, what could be, or what is your recommendation to the aviation industry in general to keep nurturing and, how can I say, retaining young talents, investing on young talents? Do you have any specific recommendation for the industry world?
If I may, I do have, if you look at the young talents these days, I would say a couple of things. So trust, kindness, but also empowerment. I think a work-life balance is also quite important. So remote work opportunities. If I really look to the younger people right now, maybe entrepreneurial and growth opportunities, with a nice structure where you will be in X amount of years. And maybe if possible in an industrial company, also a sense of ownership of the tool or of the development. I think those aspects are key for young scientists these days.
Thank you, Floris.
I agree with Floris, and if I can add, I would say that another very important topic is from the perspective of industry, they should support and encourage applied research, because sometimes there are a lot of very intriguing ideas among young scientists and scientific community in general, but at the present, in the current times, because of national but also international issues, there is no capability to investigate and test these ideas, since you would need facilities, professional figures, and so on. So I think that industry should look for all those disruptive and groundbreaking ideas and try to facilitate their investigation in an applied manner, so providing facilities and tools to explore these ideas.
Yes, I totally agree with Gianluca. From my position in the academia, I would say that more than money, minds need challenging problems. That's clear. So industry should offer challenging problems for which the industry needs to invest in research, in applied research. The mechanisms they might have, for instance, they might use industrial PhDs, partnership with the academic domain, to have this dual supervision in which they can gain from us, from the academic domain, basic knowledge and a scientific philosophy or way of approaching problems, and on the other end, providing students with a challenging application, also following up also what Floris was mentioning, right? In the sense of providing them also stocks or options about the tools they develop and so on and so forth. But it's important to for the industry to pose challenging problems to bright people, I would say. Otherwise, you can pay a lot of money, they will go and look for what they want to do.
Okay, thank you. I think that reading in the lines of your answers, you were basically saying that in the scientific community, there are lots of brilliant ideas, but sometimes it's difficult to provide enough visibility and enough, let's say, funding to these ideas to be further developed. And that's, I think, where the industry can come up into the big picture. Looking not only at the industry side, but to the applicants, to the young researchers, what is your advice to them? If you have any specific advice in terms of application to the Young Scientist Award, or even what is your advice to any student, any researcher who is entering now the ATM world or the aviation world, which indeed is a bit close. It's a close world. Do you have any advice?
The first suggestion I would say is, please do not think that this field is not looking for you, because I think I'm a great example of how much the aerospace or traffic management field is really multidisciplinary. And for my personal experience, I also would like to say how this field is at the cutting edge of applied research. For example, in my career, the aerospace has been the first applied field for neuroscience techniques. And I think that the same can happen also for my colleagues in other fields. So in general, there are no ideas that cannot be applied in this field. Just provide the best of you.
My view is that you need to think out of the box. That's clear. To lead, push your own ideas, be proactive, and while looking for a PhD position, I mean, there is a lot of bibliometrics today. So how many papers, how many presentations? I don't think that's relevant. Of course, you would need to pursue some numbers, but I think you need to do groundbreaking research. Think out of the box. It might take a while to publish, but then if you really make a difference in what you're doing, that's the important thing. And once you've done with the PhD, another recommendation is to kill your father, metaphorically speaking, right? So try to move somewhere else, try to find your own path, and to explore your own ideas, because sometimes when you do a PhD, the ideas come from the supervisor. Typically, you are not experienced yet. So that would be my another recommendation, to not only to get this Young Scientist Award, but also to kind of start developing your own career in the scientific domain, if that's what you want.
Yes, I think most of the aspects are mentioned already by both of you. If I may add one thing, indeed, I would say a project where you are definitely or highly motivated in, and the topic should definitely relate it to the industry. So for me, to win the prize, it should really go beyond research and make sure not even operationally working, but at least that you have in mind that it should work operationally in an X amount of years. So in my case, I worked with real air traffic controllers that were validating the tool. And I think that really goes beyond research from my perspective, so that they can really work with it in an ATM environment. Thanks.
Okay, guys. Thank you also for this answer. Meanwhile, you were answering and debating a little bit. I was looking at the chat, and in fact, I see that, for example, there is Bulatsa here saying that they are open to start any possible dialogue with anyone outside the company. So, I mean, this is an evidence of how there is interest from the industries to be in contact at least and start chatting, start dialoguing, start to a mutual understanding of what kind of possibilities and opportunities for both, for the researcher and for the industry. So thank you, Stefan, for your comment. Feel free to add more information in the chat or raise questions, which we may possibly answer offline, because I know that this is a very interesting topic, but I'm afraid that we are already running out of time. So I would like to thank all of you, Manuel, Floris, and Gianluca, for being here today. And this conversation to me has been extremely interesting. Before before closing the webinar, I just would like to give like a closing remark, which is about the call for the, sorry, I need to run it again. The call for the 2020 award. I didn't mention before, but whenever we receive the applications and the call is closed, the evaluation of the applications is done by independent experts. So it's not the SJU assessing the applications, but are members of the scientific committee of the SJU, who usually are professors, or anyway, they really come from the academia. So the SJU performs some legal checks and basically go through some eligibility criteria, but then the evaluation according to the evaluation criteria is performed by the members of some members of the scientific committee. Having said that, and before closing the webinar, this is the slide regarding the Young Scientist Award 2020. The call is out and is available. The deadline for applications is on the 6th of September. This is the link to the SJU webpage where you can find more and more information regarding the application, including the contest rules and including the application form. So all the informations are there. Thanking you all in the audience for having joined this webinar. I really encourage each of you to spread the voice, spread the information at your maximum extent. We really would like to receive more and more applications every year, because we definitely think that this is the future, and the future of ATM will pass through disruptive, out-of-the-box ideas which are around and which we need to be aware of and assess. So having said that, again, thank you very much, all of you. You have a good day, stay safe, and keep in touch with the webinars of the SJU, of the Digital Academy of the SJU. Thank you very much.
Thank you.